Hello and welcome you all. As we know about that the circuit, how to design a circuit, what which type of components we require to design a circuit. So these are the basic information or basic concept we have to understand. So understanding of circuit is one of the most important factor whenever we are going to know about the electronics or electrical circuit. So what is circuit? I can say that where we required control as an switch, then source as a power source, that we can say that single dry cell or any sort of cell or the any power supply, and then a load which can be work on that particular source. So as per the definition of electronic circuit is a complete course of conductor through which current can travel. Means whenever I will switch on that particular control or switch, then current start to travel, okay, from one end to another end. So the circuit provides a path for current to flow. To be a circuit, this path must be start from one end and end it on the same end. As we see, either battery or a switch, it will start from that particular positive end of that switch, okay, flow through the source and then the load, and then end it on the negative end of that particular switch or the battery. So this is a sort of, we can say that, example or the definition of a circuit. So as per the category electronic circuit and the electrical circuit, we can say that the same definition is applicable for the electronics and electrical circuit, but the electronic circuit tends to be a low voltage. Electrical circuits working on the 230 volt or the more than that particular voltage, but the electronic circuits are working on the low voltage. So this is the simple definition of we can say that circuit. But it is get categorized in two category. One is nothing but your series circuit and second is nothing but a parallel circuit. So connections types are nothing but your series circuit and the parallel circuit. We can see here in the first diagram about the series circuit. LEDs are connected in a series along with the resistor with 9-volt power supply. And in the second diagram, as we see here, the parallel LEDs are connected in a parallel along with the series resistor with 9-volt power supply. So there are two categories of circuit. One is the series circuit and the second is the parallel circuit. We can say that application of different circuits are nothing but your electronic circuits are used to make modern electronics devices. As we know that laptop, mobiles are the modern electronics devices can be designed by using electronic circuit. Electronics technology helps devices and machines to become a mobile and compress. It should be like small in size, as we are going to use SMD component, so it is very much in small size. As we know about that, nowadays all the electronics devices like laptop, tablet, smartphone are made up with the semiconductor circuit, and because of that their sizes become small. So these are the few examples of the electronic circuit, and nowadays it is on booming electronics industry, or it is lots of demand. There is a lots of demand and the growth of this particular circuit. So whenever we are going to design electronic circuits, we have to design that circuit first, then we have to implement in it on a breadboard. So we can see here the circuit which is already designed on a breadboard by using processor, by using connecting wires, by using LEDs, load, resistors and capacitors. These are the few different components we required. So if I are going to we use a breadboard, then we have to understand which type of terminals are get short. So we can see here yellow color and the green color terminals are get short, but in between that there is like some, like we can say that middle divider is there. So yellow color strips A, B, C, D, E are get short, and F, G, H, I, J are shorts with each other, means horizontal holes are linked together. And we can see here the positive and negative terminals, red color and the blue colors, are short with each other. First 5 slots of we can say that breadboard are short with each other for power supply, red and blue color. So we can see here these are the red colors and these are the blue color, which is nothing but a part of your we can say that positive and negative supply, or we can use it for the ground or the VCC supply. And these two colors, green and yellow colors, so these are the divider, this is divider in between these two, so we can connect these two. These are not shorts, but A, B, C, D, E, F are the shorts. So we can place component in vertical directions, and it may short in the horizontal direction. So these are the breadboards where we can design components, we can design place components and design a circuit. Another way to design a circuit or the proto board, we can say that zero PCB, we can say. So before implemented on the a real time circuit, we can design. Previously it was in the breadboard, and also it is on zero PCB also. We can see here the zero PCB. Then after that we can say the elements of the components, circuit components, element and the component of the circuit, which type of components we are going to use to design a circuit like this. We can say that diode. So diode, a semiconductor device with two terminals, typically allowing the flow of current in one direction. So we can see the simple definition of diode. This is the simple definition of diode. In future we can say about the different detailing information about the diode, which type of examples or which type of applications are going to use by using diode. There are multiple diodes, we can say that. Okay, we can say that simple diode, semiconductor diode, we can say that Zener diode, we can say that LED, photodiode, vector diode. These are the different diodes we can use for the different application. Second component we can use as a capacitor, a device used to store an electrical charge consisting of one or more pairs of conductors separated by insulator, is a simple definition of capacitor, and it is get categorized in different two categories: electrolytic capacitor and ceramic capacitor. There are multiple different categories for the capacitor itself. We can say that third component we can use to design a component or the circuit. So inductor, an inductor also called a coil or a reactor, is a positive two terminal electrical components that stores electrical energy in a magnetic field. Electrical energy in a magnetic field. When electrical field current is flowing through that particular conducting wire is a part, we can store the electrical energy in a magnetic field itself by using the inductor. This is the simple definition of inductor. Another component we can say that resistor. A resistor is a passive two terminal electrical components that implement electrical resistance as a circuit element. We can say in that simple definition, we can say it is used to oppose the flow of current. And basic component, we can say these are the basic components. And the last we can say that DC voltage sources or the AC voltage sources. So the voltage source is a two terminal devices which can maintain a fixed voltage. An ideal voltage source can maintain the fixed voltage independent of load resistance or the input current. So these are the few components, and which are most important part for designing a circuit. So we can say that the symbol of cell is first one. Cell is positive and negative. Battery symbolic is like this. Again, it have a positive and negative. Switch symbolic like this. We can press it as a switch. Then lamp is looking like this. This is the we can say that symbolic representation of a lamp. Then this is a buzzer symbol, ammeter symbol, voltmeter symbol, motor symbol, resistor symbol, and variable resistor symbol. These are the different symbolic representation. We are going to design a circuit. That time we need such type of information, basic information, whenever we are going to design a circuit. So that circuit which will flow a current, which have a voltage, supply voltage, and a resistance. So there are three basic information we require. One is the current. Current is a flow of electrical charges, carries usually electron or electron deficient atoms, which can be a part of your current. So current is nothing but your charges which is flowing through any conducting material, we can say. Second, we can say that voltage, a voltage or a potential difference between two points is equal to the work done per unit of charge against a static electric field to move the charge between 2 points. The voltage, DC voltage, and AC voltage, we can say, and it is a potential difference between two different points, two terminals, we can say that. This is the definition of simple definition of voltage. And third component, third parameter is nothing but a resistance. the tendency of a material to oppose the flow of electrons or the charge, we can say that is a part of nothing but your resistance. So these three parameters which are mainly observed in a hardware or in a circuit, where we can observe the current, how much current may be passed through this particular circuit, we can say that how much voltage is required to get the output through that particular circuit, and then how much resistance. So this is a particularly we can say that Ohm's law. What is Ohm's law? We can see again in the next slide itself. So as I say that resistance, so we have a resistance value. Okay, it is a part of nothing but your 4-color band is available on a resistance. So I can say that how to read that resistor code. First find the tolerance. As we see here, 10% tolerance are here. Okay, gold have a 5% tolerance, sometimes silver have a 10% tolerance. So in our example we have a silver, that is tolerance is a silver is nothing but your 10% tolerance. Then starting from the first band of color, okay, other end, we can say that this is nothing but a left end and this is nothing but a right end. Left end started with the red color, so we can say that first color is a red color, is an 2, value of 2. How it is? Then we can again, it is available in a chart of that particular resistance values. The next color here is a black, so write down 0 for the black color. And then the third color is a multiplier band, we can say that multiplier band. So this is nothing but a 10,000, means we can say that 10k. So by using this we can say that equation, we have first color is 2, second color is a black, 2 is indicated as a 2, black, red is indicated as a 2, black is indicated as a 0, multiplier is 10,000. So this is nothing but we can say that 200 kilo ohm with 10% tolerance. 200 kilo ohms, the value of that particular current. How it is calculated? So we have a resistor color coding. We can say here that black, brown, red, orange, yellow, green, blue, violet, gray, white. These are the color band, and we can say that their first band is 0. Okay, 1 2 3 like this, ninth up to the white. Gold have a 5% plus minus 5% tolerance. Silver have a 10% tolerance, and none of the color is there than 20% tolerance. The multiplier R is like this. Black have a 1, and largest multiplier with the white. So this is a way to calculate the current. So 4 band color and the 5 band colors are there, so we can calculate by using 4 band color like this. The rightmost portion is nothing but a tolerance. Here also the fifth one color is the tolerance, and remaining 3 colors are nothing but color values to identify the value of that particular resistor. So this is the way to calculate the resistor. So if we are going to design a simplest circuit, so we require a component as an LED to glow that particular or to on and off the LED. Then we require the power supply as a 9 volt DC power supply. In between that we require the 470 ohm resistor, connecting wires, PCB. These are the basic requirement to design a simple circuit. So if we start by connecting the LED circuit in series with the resistor, you must make some calculations to figure out the resistor value. Which type of calculation we required? As we know that 9 volt battery we require, then LED we require, and then resistor. So the connection like this: positive terminal of a 9 volt battery is connected with the resistor, and the negative terminal of resistor is connected with the positive or the anode terminal of a diode. Here we are going to use a blue color, and the cathode terminal of a diode is connected with the negative terminal of a battery. So this is the simple circuit. So whenever we are going to deal with this circuit, so the source voltage is 9 volt as we see here, and the voltage drop typically for the blue color is 3.1, conducting voltage for that blue color. As we know that the LED are nothing but a diode, and every semiconductor diode have their own conducting voltage. So each and every color have their own conducting voltage. For example, we can see here we have 3 volt conducting voltage for blue color. White color we have a resistance or a white or we can say that white desired current required for the 13 milliampere. So we can calculate the value, we can say by using Ohm's law. So 9 minus 3.1 is the voltage, V by I. Okay, we can say that V by I is equal to R. So V is nothing but your 9 minus 3 volt. 9 is the voltage supply, 3.1 is the conducting voltage drop through particularly diode, a resistor, LED we can say, and 13 milliampere current flowing through this particular circuit. So the value is 452 ohms resistor, value of resistor. But in a market we have a 470 ohm resistor. If we can use a 470 ohm resistor, then the proper intensity of light will get glow by using this particular circuit. So we can use a 470 ohm resistor. And then as we know that it is get calculated by using Ohm's law. The Ohm's law states that the current through the conductor between two points is directly proportional to the potential difference across the 2 points. I can say that V is equal to IR is a value of voltage. If I need to calculate the value of current, then VI is equal to V by R. If I need to calculate the value of resistor, then V by I. As I see here, we have to calculate the value of resistor. So this is nothing but a V by I. V is 9 minus 3.1 and I is nothing but 13 milliampere current. So this is Ohm's law. Then if we need to go through this particular processor or the other different components, as we go through the simple components, but if I need integrated circuit are the keystone of a modern electronic circuit. They are the heart of and the brain of the most circuit. They are we can say that a black chip with the terminals that are nothing but general purpose input output terminals or the voltage terminals or the ground terminals are associated with them. So this is a sort of, we can say that, integrated circuit. And IC is a we can say that collection of electronics component, resistor, transistor, capacitor, etc. is a detailed family logic. All the stuffs into the teeny chip, we can say that black color chip here we can observe, are connected together to achieve the common goal as in a processor. They come in all sort of flavor: single circuit logic gates, op amps, motors, controller, microcontroller, microprocessor, FPGA. So as we know that TTL, CMOS and Verilog, VSDL families are there in our integrated circuit. So on the basis of that family we are going to design a hardware. So this is a part of nothing but your integrated circuit. By using that we are going to deal with the microprocessor and the microcontroller. So what is microcontroller? Is a self-contained system with the peripherals, memory and a processor that can use as an embedded system. Nowadays it is a part of your IoT, robotics and all. Most programmable microcontrollers that are used today are embedded in other consumer products or machinery, including phones, peripherals, automobiles, household appliances, or the for sort of computing the system. So microcontrollers are a part of your, we can say that before that we can say that integrated circuit, and after that microcontroller. Nowadays again it is in advanced way are going to use in microcontroller purpose. Another name of microcontroller is embedded controller. Microcontroller are used in automatically controlled device, including power tools, toys, implantable medical devices, office machines, engine control, home automation, agricultural purpose. These are the different appliances or the applications of microcontroller. By using microcontroller we can design a small sort of circuit, and this can be used for the advanced application itself. So this is the requirement of designing of circuit. As I already discussed about that, the basic component of the circuit, breadboard of the circuit, zero PCB of the circuit, how to design a component, which type of component we require, resistor, capacitor, inductor, diode. These are the components we require to design a circuit. And then for the integrated circuit we require a microcontroller. By using that microcontroller we can design a like complicated circuit in a small size, and we can perform many applications by using this particular microcontroller and the hardware circuit. So this is the basic detail of the hardware and the circuit. The requirement of a circuit, the word is circuit, is a combination of components with the input and output. So this is all about the understanding of circuit. If you like this lecture, you can just like and subscribe my video channel. Thank you very much.